This is the agenda for today. Then we will look into the preparation for these jobs. Let's talk more about preparation, and this is what maybe you need to get when you get interviews. You need to be prepared to answer questions across a lot of different things. So these are some of my thoughts that I think you need. Again, I'll talk about that while I discuss the preparation. It varies a lot based on the kind of role they're hiring for. That's why I made that distinction between generalist data scientists and specialist data scientists. If you are interviewing for a specialist data scientist like a computer vision or NLP, your interview process will be totally different from the kind you would get as a generalist data scientist. So please make sure that you read the job description and are sure about what you're applying for. Anyway, we will go to the preparation, but there are some basics that are common across these two. So let's look at that. Let's talk about projects, right? Even before we talk about the kind of topics that you will need, if you're not there in the field already, building projects is a way for you to show that you can actually do something. You can actually build data science projects, right? So you have to know how to build projects. We've already talked about how you can build right from start till the end. You have to be able to show that, right? A lot of the interviewers will ask you about, let's say you talk about building a recommendation engine, right? So how did you go about building it? What were the data sources? Why did you choose that? How did you handle missing values? Or maybe what was the data set balanced? What were the statistical techniques that you had evaluated for building that? Did you even need a statistical technique? So questions like that, right? All these kind of questions will come up in the interview. So if you have done projects, please be prepared completely about them, right? Be prepared to go in depth on the projects that you have worked on, regardless of you being a generalist or a specialist, because that is what is something that you have worked on and you're expected to know that pretty well. If you've done a project and if you say that, I don't know, I just did this because, yeah, I just found this somewhere and just did this without being able to reason your choices, that's a problem, right? Like you don't know what you're doing there, right? So make sure you know what you're doing in the case of your project. And if you know the why as well, then it's fantastic. If you know why did you do X over something else, great. So understanding deeply helps you stand out more when you say, okay, this is why I chose a random forest over a logistic regression, because maybe the number of features in this case made more sense. So you have a reason there. And then you can also say that maybe a decision tree, I wanted to make it more interpretable over a neural network. So things like that, right? So if you know why you're doing a choice, why you're making a choice, please be prepared to talk about that. And this is what will come up in any of your interviews, the kind of projects that you've done and the kind of choices you've made during your projects. And this is crucial. So please be prepared to talk about your projects. Please know them in depth. If you've worked in a team previously on a project, talk about your role in the project. Talk about other people's role as well and how that helped you improve your role, or how were you coordinating and collaborating with them. So when you're talking about a group project, how did you collaborate with the other person and what was your role? And again, when we talk about your role, of course you have to be very specific on like it's like, again, an individual project, but then these two things, right? So please do projects, and when you do them, please do understand what you're doing as well, and try and understand the methods that you're using, try and see why you're doing what you're doing. And this will help you answer all the questions that come up in an interview. So this is one tip for you while you're preparing. Please revisit your projects and then understand all the methods you've used in those projects. So a little bit on the kind of different topics that you can work on. And as we saw earlier, data science can be broadly defined as data science equal to programming / hacking plus math / statistics plus the domain knowledge. And it's a combination of all these three things. So please be prepared to answer questions on each of these subsections. Again, a lot of these questions will vary depending on your background. If you come from a math background, then it's likely that the interview is going to be math heavy. If you come from a programming background, maybe programming heavy. If you come from a domain background, maybe domain heavy. And also the background of the interviewer and the company and the role. So it's a combination of all these things that will lead to the questions that are going to be asked in an interview. But from your side, you have to be prepared on all of these different subsections. So please do that. And though you're not expected to be as good a programmer as a typical programmer is, or as good a statistician or a mathematician as a typical mathematician is, you're supposed to understand what is happening, right? You're supposed to know what is happening and have a basic intuition for everything. Understand the workflows. Like maybe you might not remember all the equations at any given point for a given algorithm, but maybe you understand intuitively how it works. And given time, you can derive the equation or you can write the equations, right? Because you understand it intuitively, you can come to that. So just prepare for it in that way. Now let's look at the different categories we're talking about. Programming or hacking skills that we mentioned already. So you should know how to program. This is, I think, a hard requirement nowadays because a lot of the companies are building digital products and you won't be able to do anything if you can't program, right? You won't be able to, let's say, even SQL, right? If you can't write SQL, you won't be able to query data. You won't be able to get data out of your database. How are you going to do any analysis, right? So you should know how to program. That's a bare minimum. Ideally, right now, because the market and the industry is working a lot in Python and R, one of these or both of these programming languages is something that you should be concentrating on if you want to be in data. Again, it's your choice which language you want to work on, Python or R. A lot of companies I see are working in Python because of the advantages of using Python across the stack. Like even in my in the company I was I co-founded and I was the CTO, we worked on Python across the stack, even the web development and for the analysis for the data science part as well. So everything worked seamlessly there, right? If I were to do analysis in R, then I have to do a lot of shuffling there. So, I mean, a lot of R people are going to not like what I'm saying here, but yeah, okay, I can't control that. Anyway, so my point is learn one of these languages really well so that you can really write programs to be able to do analysis, the kind of analysis you want to do. Understanding of computer science fundamentals, data structures, algorithms, space-time, time-space complexity is helpful. It really helps you improve your code. When you start off, you might be a bad coder. When I say a bad coder, there are a lot of things there, right? Which good coders know, like how do you write clean code? How do you organize things into functions? How do you modularize things? How do you parameterize stuff, etc., etc. These are small things. But I mean, I'm not even going to the part where you can improve the performance of the algorithms you are writing, or even right when you're doing data munging, right? How many for loops are you using? The more for nested for loops, the likely the number of operations you're doing is higher. So how can you reduce that? Things like that. So these things again are not required if you're a total beginner in programming. Don't even have to think about that. Even the third point is understanding of different programming paradigms: object oriented, procedural, imperative, functional. Don't have to worry about all that initially, but as you go further, because more and more code will be written, like for example scikit-learn, right? Scikit-learn is a Python machine learning library. It's a machine learning library in Python, and if you look at their code, they have written in an object oriented way with a class and an instance and all of that. Some people like to write in a procedural way. Some people like to write functional code, these are different ways of writing code. All right. So you will learn this. I mean, it's good to learn this. It's not mandatory, and this is not asked during the interviews. But then if you've given, let's say you're given a take home task, right? If you demonstrate any of these things, if you demonstrate that you know what a function means, you know when to convert multiple lines into a function, or you know how to write a class and define the objects and call them and pass parameters, if you can show all of that in the take home task that you're given, great. I think then you can show that, hey, you understand these concepts, you're likely to write clean code when you are hired, and that's a big plus point, right? So that's the only thing. I mean, I know on day one all of these things are not required. On day one you should know just, okay, how do I get my data out of the database or of the CSV? How do I do this analysis? Even to do the analysis, you need to know a lot of commands, right? So yeah, this is on programming knowledge. The ways you will be tested for these in interviews are the ways I was tested. I can think about that. I can tell you about that. Was I was one of the companies gave a hacker rank test. For those who don't know, HackerRank is a website where you can practice different programming problems and stuff like that. And also they have a product which they sell to companies to evaluate people and eliminate people on the first round itself. So I applied to a company and they gave me a HackerRank test as the first round where I had to write 2 programs. It was a data scientist role where I had to write 2 basic programs. I think not reversing a list, but it was, yeah, one of those kind of programs, right? So that is one place where your programming knowledge is required. Another is the take-home test, which is another format where you are given a data set and a question, and you're asked to find certain inferences, right? So then you're expected to write maybe a Jupyter notebook or a script and give it back. So in one of the interviews, I had to do both. I had to write a Jupyter notebook. I had to show how I would productionize it as well. So I had to write functions, create an API, and give it back. So this was one interview that I faced. What else? Where else did I have to program? Okay. Another experience was pair programming. I don't know if you've heard of this, but this was also after the lockdown had started. So it was like the other person would be sitting on a computer on the other end, and he would give you a task, and then you had to basically write a program to count X, something like that. I don't know, count these stars or something like that, right? So there was a program that I had to write. And again, it's very similar to a whiteboarding kind of role, because it was lockdown. That was what was done. So the other person will be listening to you as you speak out loud and solve the problem. So these are the different kinds of programming problems that you would get while applying for data science jobs. Okay, math knowledge, understanding of the basic concepts in probability, statistics, linear algebra, and calculus. Concepts in probability might include events, random variables, Bayes theorem, conditional probability, joint probability, etc. So I've been asked questions on most of these things, on random variables, Bayes theorem, events, not on joint probability. But yeah, so this is like basic probability that is asked. Concepts in statistics might include measures of central tendency like mean, median, mode, or measures of variance like standard deviation, variance, statistical tests that you could use to maybe check correlation between two variables, and depending on the kind of variables, right? If it is a categorical variable or a nominal variable, all these things come into picture. Hypothesis testing is one. Experimentation. How do you do hypothesis testing? What is so where does it use? Hypothesis testing is essentially A/B testing, used a lot by marketers. So how do you determine the sample size? How do you stop? When do you stop your hypothesis test? What is the metric? What is the z-score? What is the p-value? How do you calculate a p-value and stuff like that? That is basic statistics. And linear algebra. I haven't been asked a lot of linear algebra questions, but I thought it would be good to put here so that you can also revise. Like matrices have different operations, right? Like what is the rank of a matrix, and what are the how do you do dimensionality reduction in matrices? So PCA is principal component analysis. This was also asked in one of the interviews where I was asked to explain it mathematically. How does PCA work, right? So things like that. Concepts in calculus might include differentiation. Again, like we saw right earlier, you were asked to explain back propagation. If you say you want to be a deep learning computer vision scientist, data scientist, you would be asked to show the differentiation of the weights while doing back propagation. So things like that. So I have put math knowledge and statistical and machine knowledge as separate, because this is an entire topic in itself. So math knowledge is more geared towards probability, statistics, algebra, linear algebra, and calculus. So these are like math, right? This is coming from math. And then one branch of statistics is statistical learning or / machine learning. And this itself is huge. Like math also, you don't need to know everything that exists in probability. You don't need to know everything that exists in statistics, but a lot of the things around Bayes theorem, a lot of the things around mean, median, mode, deviation, variance, hypothesis testing. This is math knowledge. This is statistical and machine learning knowledge. So what you would need to know in this is understand all the different concepts in statistical learning, like supervised learning, unsupervised learning, reinforcement learning. You should be able to conceptually explain what you mean by supervised learning, the kind of data sets you can work on using supervised learning, the kind of problems you can solve, like for example, classification, regression, the different algorithms that you can use for each of them. I'm not going into the details here about the techniques like linear regression, logistic regression, SVMs, random forest, decision trees, and deep learning neural networks, etc., etc. These are the different techniques you could use for all of these problems. K-means clustering, hierarchical clustering, etc., etc. Those are unsupervised learning techniques. These are different methods, and like there's a framework that I use to think about them, which is representation, evaluation, and representation, optimization, and evaluation. So representation is the equation used to represent that particular algorithm. Optimization is the optimization technique that you use to improve the performance of a model, and evaluation is the metric that you use to measure and evaluate the performance of your models. So what are the different optimization techniques? It could be a gradient boost or any other stochastic, gradient descent or stochastic gradient descent or any other technique that you use to optimize your algorithms. Evaluation metrics could be your accuracies, your precision, your recall, or your AUC ROC curve that you use, or your false positive rates or your true positive rates. So these are different kinds of evaluation metrics that you could use to see the performance of your models. And then maybe concepts like cross-validation, k-fold cross-validation. How can you improve the performance of your model? How can you split your data sets, right? Train, test splits, validation split. What are the different ways in which you can split your data sets? How is your data set collected? What are the different distributions that exist? This is going a little bit back to the math. What normal distribution or binomial distribution? What kind of events can be modeled using these distributions? And one more thing about, when you split your data set, is it a stratified split or is it a random split? So all these things are important for you to know, for you to be able to tell the interviewer. Maybe things like if there are missing values, what are the techniques that you would use to handle that? If there are outliers, what are the things you would do to handle outliers in your data set? Or if you have a lot of dimensions, right? How can you actually reduce the dimensions without losing a lot of information? Things like that. Or what are the different techniques that you use? What can you do, right? So all these things, whatever I'm telling here are questions that have been asked to me in one or the other interview. So these things are required. And the biggest thing about data science is that you never know what kind of question you might be asked. Depending, like I said, it's a combination of all of these things, right? It comes from math, computer science, statistical learning, and the backgrounds of the interviewer and your background, all of these, the projects you've done, all of these matter.